The Ben Heck Show is brought to you by Element 14, the electronic design community where you can connect and collaborate with top engineers from around the world. Join now at element14.com. Hello and welcome back to the Ben Heck Show.
Hey Ben, we get to finish Hackmanji! So, for the last couple months, we've been working on a board game that's based on the board game in the movie Jumangi. Except in the movie, you have to run away from elephants and fight off monkeys and crazy things for your pawn to move. In our game, you have to solve logic gate puzzles in order to make your pawn advance.
That's right. In the first episode, we mechanically made the pawns move with magnets.
And microchips.
In the second episode, we created the logic puzzle portion where you would interconnect real integrated circuits to create solutions to the puzzles. In today's episode, we're tying everything together. We're gonna finish building the case, decorate it, make it look nice with art and whatnot, and then create the program for the microcontroller that will actually turn everything into a game. And it will load the puzzles off an SD card.
Yeah.
Let's get started.
Amazing hacks.
Where are my dragons?
Inspired designs.
Oh, look, I knocked some hot glue loose.
Regrettable acting.
I want to live in a world with Star Wars again!
Each week, Element 14's The Ben Heck Show brings you innovative projects using electronics, engineering, and more.
Okay, now that I've made the enclosure for the top half of the unit, I need to put some items into it. So I've already glued in our LCD screen and the speaker. Now I need to wire up some plugs, so this is nice and modular. There'll be a video in plug, an audio in plug, and then also a power plug going to the LCD.
Ben,
What?
those don't flip up like the movie.
What do you mean like the movie?
Well, like in the movie, this like flips up and then the pawns are in there. This
You mean
like
Hackmanji the movie or Jumanji the movie?
in Jumanji the movie.
It's been 20 years since I've
The
seen that
movie
movie.
that this game is based on. You have to make it as precise as possible.
So we need hinges, you're saying?
Yeah,
Okay.
because like this.
I personally think these are pretty cool.
Wait, I don't know.
It's like you're sawing a woman in half, you know, like a magician's trick.
This doesn't.
You're holding it wrong.
This is a game. It needs to be simple for children.
Okay, fine.
Okay.
That's true. We want Kristen Dunst to be able to play this easily. Well, I guess we could recut these as doors, but we're gonna have to put some sort of magnetic clasp in this lip here. So then how are you gonna make your door attach to the magnetic piece?
Well, so if we have tiny hinges that we can put, you want it to go this way or this way? Because in the movie
Well,
it goes this way.
yeah, but we don't want the hinges to break the screen, so we'll probably have to put them at the top or the bottom.
Okay, so if we do it like that, and we can have hinges here, go,
Yeah.
and then we can put magnets in here.
Okay.
Yeah, and then since this is kind of too thin, this is what, 3mm?
Yes.
It's too thin for a magnet. So what if we just put like a steel strip on here? Maybe from like a,
Oh, on the underside?
yeah,
All right, I'll cut the doors. You find some steel.
okay.
But it has to be real steel. Here's where we are so far with Hackmanji. We have the logic gate portion done. The servo portion is just about ready to go. We just have to install the arms on it. Then up here, we have our compartments for our pawns and our cables, as well as a speaker and a screen that will display the information while you're playing the game. And these panels close via magnets and little strips of steel. So it took a while, but I lasered some detail for the lid. This is a design that Karen and her friend worked on. I'm going to close it up and glue that together. We also have hinges in place now. Hackmanji. I'm going to start detailing this Hackmanji board game. We're going to use soldering irons to kind of create some burns in the wood just to make it look interesting. I don't have a wood burning pencil, but I think the irons will be close enough. And of course we also have this blowtorch, which you know is always handy. Always keep a blowtorch around. And a fire extinguisher. I'm gonna burn the edges just to give it a little bit better look. I'm also gonna stain it with a dark red mahogany, a very good year. The secret to making things look good is to make them look like crap. So we've been distressing this Hackmanji box for about an hour now, adding scratches, gouges, whatever else. So yeah, it's actually looking pretty good. The stain does a pretty good job of hiding the slot and tab laser cut pieces. So I'm gonna just add a few more burn marks and a few other things, and I think it's pretty much ready to go, although I may stain some of the parts of the inside as well. It's fun, it's like, oh, I get to whack things with a hammer randomly and it accomplishes my goal. Now I'm testing a servo driver with the propeller. We didn't have very many pins left actually, but I was able to find 4 contiguous pins to drive the 4 servos. So what I'm gonna do next is basically figure out what the extremities are, like the far limits of both ends of the servos. There is about a 3-to-1 gear ratio on these, so we don't actually need the full length of the servo to actually make the piece move all the way, but we do need to write down the numbers. So this program uses the pulse width instead of degrees. It doesn't really matter to us, we just need to figure out what the best number is. So what we'll do next is we'll figure out the extremities of all the servos. And if we figure out one of them, the rest should work the same because they're all mounted in the same orientation going clockwise, even though I just moved my hand counterclockwise. But if you watch this footage south of the equator, it'll obviously fix itself. I've got the audio driver attached, so what I can do is go in and make it play audio to coincide with the dice. Let's give it a shot. Very intense. All right. And also earlier, Max recorded Felix doing some dialogue like, "Player 1, it is your turn," and stuff like that. So I'll get those things edited and put onto the SD card along with some music and some other sound effects like beeping when you're almost out of time. And then we should have everything we need to actually start programming this. So I've got some test code running here. I need to find the beginning and the end of each one of these arm positions. There could be a little difference between each of them, so I'm actually gonna have different variables for each player. So you start there and you end there. So I'll find the positions and then I'll divide by 23, which is the number of moves you'd have to make to get here. And then I should be able to move all the pieces. One thing I have to also keep in mind is I don't think I could bring all of these to the center because they would collide. Of course, there can only be one player who wins naturally. But yeah, if you look at this here, yeah, see how they would hit? So I want to make sure I keep a minimum distance between the players. And then I made some marks here, if you take a look on the top. So this lines up with that, and that's the start position. And then E lines up with end for the end position. The reason I marked that is so I can remove the arm, and as long as I put the arm back with the servo in one position or the other, it will line up. Basically, it's a memory. Because if you move this arm and you move it like an entire tooth rotation, there aren't that many teeth. So the teeth are actually a very coarse measurement. You get a lot more granularity out of the servo itself. But yeah, this looks pretty good. So I'm gonna figure out the numbers for each one of the players, write them into a text document, and then I can finally start making the pieces move in the game logic itself. Yeah, this is the last piece of the puzzle. All right, the parts. So here are some shift registers to do the lights on the logic board. It's a 5-volt regulator, which is powering pretty much everything. The prop dev stick board, along with the SD card, that's operating the system. This is not being used. Felix has actually combined the audio and the video into this plug. This is the power plug for the video. We used a USB cable because it's shielded to send the data to the servos, because you have power, ground, data, 4 lines in here, 4 servos, so it was a shielded cable. And here's an LM386 audio amplifier for the sound. And then there's a bunch of resistors laying everywhere. It's kind of a mess, but it will work. All right, so yeah, this is pretty much all wired up. I just gotta continue programming. I heard the recording that Max and Felix made where Felix said Hackmanji when the game was won, and it just didn't have enough oomph. So I think we need to re-record it. So guys, here's the plan. So we'll go 1, 2, 3, Hackmanji!
Yeah, that clipped.
Oh,
Yeah.
sorry.
Oh yeah.
Hackmanji! 1, 2, 3. Hackmanji! Max recorded Felix saying a bunch of lines of dialogue for our Hackmanji game, including the word Hackmanji when you win the game. Anyway, what I've got to do now is take all the lines from the script, which is only about 7 pages, and they all have WAV file names assigned to them. So I have to go into Adobe Premiere, edit everything, and export it. So there's basically like 4 versions of every line, and then, multiple lines for which player is up, if you win or lose. I'm also gonna export some public domain music that we found. Like we have the music that plays when you're doing the puzzle, and a faster version when you're almost out of time with the puzzle. So I just gotta export these all out to WAV files one by one, which is kind of tedious, but whatever. And I'll just reference my script as I go along. And once I've done this, I can finally start the final programming, finally. Oh, and I have these headphones on, so my coworkers aren't being driven crazy by the sound of Felix saying, player 1, you're up, player 2, you lose, blah, 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 blah. I'll just keep the crazy internalized. Well, now we're pretty much just down to the programming part of this project. I'm starting to layer in all of the sound effects that I edited from Felix. So right now, it's just endlessly rolling the dice and making a lot of obnoxious sounds when it does it. I'm going to put in some code so that when it finishes rolling the dice, it will announce what dice was cast in Felix's voice. Let's see if this works.
6, 1.
Cool. I got the music to play, although right now I'm only having it play the first 1,000 sectors and then it loops. The reason for that is if you play the entire song and it gets to the end and loops, there's like this audio sound. And I was trying to figure out what it was, and I think the answer is it's just metadata. So here's the WAV format sound. And if you scroll down, you can see where the music is, right? So this is all the music. But then if you go to the bottom, you see metadata. So a lot of programs tack this on to the end of a WAV file, and it's gonna tell you things about how it was created. In this case, it's gonna be like Adobe Premiere, what the date was, yada, yada, yada. So my driver basically takes the size of the file and divides it by 4. So it's stereo and then 2 bytes per channel. However, that doesn't exclude the metadata. So the metadata is, basically making a stupid noise at the end. So this is gonna be my attract mode music. Man, it takes forever to go through these big files. Yeah, see how it says packet end, which means there's probably an X packet begin. Oh yeah, here's all the metadata. Why do we need all this? But this, when it goes to the speaker, just sounds like bleh. Here we go, X packet begin. All right, so let's just lob that off. Well, actually, I'm not gonna erase it, although I could. What I wanna do is I wanna see how big it is. Okay. Hey Cortana, open calculator. Oh yeah. Boy, this is super fast. That's way faster than I could have possibly opened the calculator myself. 3D 08, and that's the length of it. Decimal, 15,624 bytes. Okay, let's divide that by sectors. 512 bytes a sector, 30 sectors. All right, so what I'm gonna do is I'm gonna go into my code. I'm gonna tell it not to loop. However, let's go here. Okay, find SFX entry, blah, 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 blah. If which channel equals 3, okay, if loop end equals 0, which means automatically loop. Loop end equals SFX total sectors. Okay, let's minus 32 just to be safe. Okay, so now in theory, that should automatically lob the metadata off the end and give us a clean transition. But just to be sure, let's open another one of these files. This is the normal game mode file. It's probably gonna have just as much crap at the end of it. Yep, all right, so I'm happy with that 32 sectors. Let's see if it makes a difference. Okay, I stood here for 2 minutes waiting for this song to finish, and when it looped properly without any noise. So yes, lobbing those sectors of metadata off the end of the file, that worked. All right, so the next thing I need to do is separate out the SD card function so that the system can ask for a puzzle while the music is playing without interrupting the SD card reading the music.
Welcome to Hackmanji. Push 1 to start. Push step to add players. A magical world of wonder awaits.
Well, how can I resist?
Player 2, added. Player 3, added. Players removed.
Oops. Got to work on the D-bounce.
Added. Player 4. Added. Players. Wait. Player 4. Added.
It's like Harry Potter shooting missiles at someone.
Player 4. Added.
Hakuna Matata!
Player removed.
Okay, well, I'm going to tweak the D-bounce a little bit, but it seems like the main menu is working. So basically, here's where you add the players,
Welcome to Hackmanji.
and then when you're ready, you push run. Okay, time to work on the code. I'm removing a few things, such as the serial driver, because we don't have very much RAM left. In fact, we're down to about 1K, because the last 3,000 longs are required for the display. But that's okay, I think I can make it fit. So here's what we do. We set up all the inputs here. We build a list of folders. And then down here, we load the puzzle file. So what we did was we combined all the puzzle files into a single puzzle file, which is right here. So if you hold the run button while the system boots, it will load a test puzzle file, else it loads this puzzle file that Karen put together. So once that's done, we go into basically our main loop. We reset the number of players and the state. We put all the pawns at the beginning. We turn off the lights. We play some music, and then we go into a track mode, which is where we basically wait for the player to start the game. So we just have a timer here, and we look for the buttons, and if the step button is pressed, we add players, and then every 2,000, 7,000, 12,000 cycles, it has Felix saying something like, "Welcome to Hackmanji." So when you push this run button, run state changes to 1. So we go back to the main loop, and that means this will exit, and then we reset the game again, and then we make the actual game repeat while run state equals 1. So we do a turn, and we increment the players. And if a player wins, then we change run state to 2, which will cause the game to basically be over, and then the whole loop restarts. So let's take a look at the 1 turn. Okay, so we announce who's up. Player 1, you're up. We change our text, and then we just have a loop here while we wait for the player to push run in order to cast the die. And once they do, we do the die roll animation. We get the puzzle off the SD card, and when we get the puzzle, it parses the ASCII into actual binary that the computer can understand. Then we play some frantic music, and then we do die result equals run puzzle die result. So if you solve the puzzle, it's going to return the number of spaces you should move. If you fail the puzzle, if you run out of time, it'll return a 0. Okay, so this is the real meat and potatoes of the game. It's a repeat loop, and the only way to get out of it is to return out of the function. So we either return a 0 or the number of spaces you should move. So what it does is it actually checks all 4 cycles every time the system beeps. A viewer actually emailed and said, hey, you've got an error in your logic in episode 2. You can't just check boop, 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 boop. You can't just count 1, 2, 3, 4 correct states. You have to do it every time, otherwise there's a possibility for a false positive. And I double checked and that person was right, so thank you. Basically, we have a bunch of codes here, so you can push the step button to manually cycle through, or you can push run to turn the timer on. I have a bunch of different sound effects. So it'll go boop, 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 and on the last cycle it goes boop, so it'll be like boop, 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 boop. And then if you have a cycle correct, it does a double beep, so it'll be like boop, boop, beep, beep, boop. So you're like, oh, I know, cycle 3 is correct. So I just put in a lot of stuff there that will help the player understand what's going on. But yeah, it looks like we pretty much have everything we need. So I'm going to take this over, hook it into the Hackmanji game, and start testing the code. Oh boy, let's see what I get.
Okay.
This one looks pretty easy.
So it's
On.
Both, off.
Oh, so it's or.
On, off. Yeah.
Well done.
Yay!
Like that
you
positive
got one-
reinforcement at the end?
I only get 1. It's 30 seconds. All right, on. There's nothing happening over here.
It's a single cycle puzzle for some reason. Just go through a NOT gate, that should solve
Yeah.
it. Ah! Yay! You won 1 space!
Bravo, well done.
All right, Felix, it's your turn.
Yeah, it moves slightly. Oh god, he got a complicated one again.
This is almost what I had before.
I think it is. Well, we can solve it this time, maybe.
Can we? Okay, so these are on every time. Or
No, it was.
There's 2 cycles. There's that cycle.
Put it into run mode.
You know, this is my turn.
We're trying to.
welcome to help.
Okay, go ahead and help, Felix.
Let me do this here.
Okay.
You
all you, man.
guys are taking my turn here. Well, you guys, come on.
We're trying to help.
Give me a chance.
I was just plugging stuff
right.
in.
All right. Well, I don't. Okay, cycle 1. These are off. All right.
You lose.
Yeah. Well.
Well, Karen, we finally did it. We finished the Hackmanji automated board game.
Woo! It's pretty cool.
Yeah.
I think we need to like tweak it a little bit, but I mean, considering how much time we've spent on this and how much time people spend developing like non-electronic board games, I think this came out really good.
Yeah, I mean, any tweaks we would do would mostly be software. Like with the puzzles, we combined all the puzzles into a single file. I think we should probably go back to the original idea of having 6 separate files, 6 different difficulties of puzzles. So if you roll a 1, you get a really simple puzzle. But if you roll 6, then you get a harder puzzle. Yeah, so you feel like you've earned it.
Yeah, we talked about doing that originally, but we thought it was going to take too much time to separate all the puzzles and figure out all the timing. So yeah, I think that's something that we can kind of debug as we go. You know what else would be helpful? Because a lot of times while we were playing, we're like, oh gosh, and you're trying to remember what it did in previous cycles. So if you could have like a little dry erase board there, so you could like take notes, that would also be nice.
So you're saying like etch here, the truth tables, and then put a little dry erase board here?
Yeah,
Yeah, that could work.
we good.
So what do you think of the Hackmanji board game? What would you do differently?
Let us know on the Element 14 community on element14.com/TBHS.
Where you can also read about other upcoming episodes, builds, and special events. We'll see you next time.
Ben, why are you wearing a wig? Did someone submit it as an idea on the Element 14 community?
No, it's not really that great of an idea. But really great ideas we do like. So each month we take the top 5 build ideas from the Element 14 community and discuss them.
Wait, so is there a new top 5 build segment out right now?
Yeah, and you can check it out by clicking the link below.
Misa think you should click the link below.
A magical world of wonder. Welcome back to What My Shirt Says. Hello and welcome back to the Ben Heck Show.
Sorry, I got lost. One more time.
The Ben Heck Show is brought to you by Element 14, the electronic design community where you can connect and collaborate with top engineers from around the world. Join now at element14.com.